Dependency injection complements the interface pattern we discussed in the previous lecture. As a reminder, we talked about interfaces as the better mechanism for communicating between classes in order to make the code more modular and flexible. We finished the lecture with an open-ended topic: how to inject a concrete implementation into the interface so it can be used by the calling code. And the answer to that question is the topic of this lecture: dependency injection. Dependency injection is defined in Wikipedia as a technique whereby one object supplies the dependencies of another object. Now, this might sound a bit complicated and, well, academic, but in reality, it's quite simple. Let's look again at the example we discussed in the previous lecture. We had a main class that calls the calculator class. In this example, the calculator is a dependency of the main class. The main class depends on it in order to be able to function correctly. Using the dependency injection technique, we are able to inject a concrete implementation or a class to the interface representing the dependency without the main class knowing which concrete implementation is used. If we will look closely at the code, we can see the dependency injection happening at the getInstance line. In this line, the getInstance returns a class that implements the iCalculator interface. Note that the main class has no idea what class it is. It can be the class we saw previously or a completely different one. The only thing known is that this class implements the required interface. This way, we created a middleman between the main class and the calculator class, or in other words, we eliminated the strong coupling between the two, making our code much more modular and flexible. Now, the real question is, of course, what is happening within this mysterious getInstance method? Well, the answer is actually quite simple. This method, often referred as factory method, simply executes some logic and decides which class should be injected. An object is then instantiated from the class and returned as an interface. Let's look at some possible implementations of this method. The first implementation is the simplest. It simply returns an instance of the calculator class. This implementation has no logic at all. It always returns the same class. Although seems a bit odd, this implementation still carries value, since even with only a single class, the use of a dependency injection helps us to create a modular code that is not tied with strong coupling and allows us to switch to another implementation without the calling code being aware of that. Now, let's look at another implementation. This implementation is more sophisticated in that the calling code specifies a parameter that helps the method decide which instance to return. In this case, the calling code specifies which type of calculator should be used. As you can see, the method examines the calculator type received, instantiates the correct class, and returns it. Note again that the calling code has no idea which implementation it got. It always works with the interface. A very common variation of this example is to define the parameter in a configuration file. This way, the factory gets no parameter at all, but reads the parameter from a configuration file. This is a very common pattern in data access layer implementations, where the database type to be used is stored in the configuration file, and the factory method reads it from there and decides which data access layer implementation to return. Up until now, we saw examples of dependency injection using a factory method, but there are actually other types of it. One of the most common types of injection is a constructor injection. Using constructor injection, the class receives instantiated interfaces in its constructor and uses it in the class's methods. Here is an example of such an injection, this time in .NET Core. As you can see, the class's constructor receives an iLogger interface as a parameter and can use it immediately. The framework, in this case, instantiated it for the class and no further action is needed. The main advantage of the constructor injection pattern over the traditional pattern is testability. A class that gets injected in its constructor is much more easy to test. The test method can instantiate the class with mock objects and simply run the test. This example demonstrates that. Note that the test method instantiates the class with a mock logger which does nothing, and the tested class has no idea about it. From its point of view, this is a normal logger with full functionality. So this concludes our discussion on interfaces and dependency injection. It's not trivial, but once implemented properly, the result is a modular, flexible, and easy to maintain and modify code. Give it a try. You may get a bit frustrated at the beginning, but in the end, you will see the light, believe me.